Hello student, welcome back to the computer networking and security one more session. In this session, we will discuss IP version 6. So in the previous session we have seen IP version 4. Now what is the actual motivation behind the IP version 6? We know IP version 4 is like 32-bit address, 32-bit. 32-bit in the sense like you will get here 2 raised to power 32 address, 2 raised to power 32 address, 2 raised to power 32 like around 4 GB address you will get here in IP version 4. But in the early 1990, actually, the Internet Engineering Task Force began to develop the successor of IP version 4. The prime motivation for this one is the realization that the 32-bit address space was being completely used up, and each day or every day new subnets and IP nodes being attached to the network. So to respond to this need for large IP address, they come up with the new idea, that is 128-bit address that will provide large IP address space. Second one is the motivation. Second additional motivation is the design. So they designed the IP version adder in such a way that which helps in speeding up processing and forwarding, and it provides or facilitates quality of service. So now IP version 6 datagram format compared to IP version 4 is, first one is, it is a fixed 40 byte adder, fixed length 40 byte adder. If you compare our IP version 4, it is a 20 bytes adder except option field. Except option. If options are there, then the adder size will increase. But in IP address 6, it is a fixed 40 byte adder. There is no option field. So which will facilitate or which will help for faster processing of the IP datagram. And second one is no fragmentation is allowed. That I will discuss later. Now we will proceed to actually the format of IP version 6. The format of IP version 6. So as I said, IP version 6 is 128-bit address. 128-bit address in a sense like it will provide around 2 raised to power 128 addresses compared to IP version 4. IP version 4 used to provide around 2 raised to power 32, around 4 GB. So here you will get the address, a large space of address space, compared to IP version 4. Then other than that, we can see different fields in the IP version 6 datagram format. That is, one thing is version. Second one is it is a type of traffic class. Traffic class, actually it is not priority. The other name here it is, let me change it, traffic class. It is traffic class. Third one is flow label, and next one is payload length, next header, off limit, source address, and destination address. Let me now explain one by one. Like first one is the version. So version is a 4-bit. Definitely the version, this indicates IP version 6, and it helps the router to process the datagram in the particular manner. Second one is traffic class. So what is traffic class and flow label? Now we are going to discuss what is traffic class and flow label. Actually, flow label helps in handling, flow label and traffic class helps in handling the packet with the priority. That is, labeling of the packet in such a way that it belongs to particular flows for which the sender requests to handle the packet. For example, like in case of real-time service, or I can tell example, for example, like audio video transmission might be treated as a flow, but some other application like file transfer, email might not be treated as a flow. So it is possible that traffic carried by the high priority user, those user who are requesting for high priority services, for them it is possible to give required service by differentiating the flow with the high priority flow or low priority flow, something like this. The IP header version 6 here has 8 bits. Here also you can see it has got 8 bit which is allocated for traffic class. So which is used to give priority to the datagram within the flow. So that is the function of traffic class and flow label. So both traffic class and flow label will handle the flow and it will give the priority to the different flows based on the applications, based on the services required by the user, etc. That is the one you think. That is the one thing you should know here. Third one is payload length. So you see here 16 bits are allocated for the payload length. So what is this payload length? Here actually 16-bit value is treated as an unsigned integer. Here 16-bit value, it is treated as an unsigned integer giving the number of bytes in the IP version 6 datagram following the fixed length of header. What is the fixed length of header? Fixed length of header is 40 bytes. So it tells what is the actual size of the datagram. What is the size of the datagram following the 40 bytes of header length. So this helps the router to process the datagram properly. Next one is the next header. This field identifies the protocol which this field identifies the protocol to which content of data to be handled. So in case of IP version 4 also we have same thing here, like we have that. I will take you to this one. You can see in the IP version 4 we have something like upper layer protocol. Instead of upper layer protocol, here in IP version this is the IP version 4. Instead of upper layer protocol, here we are using next header. So that tells which of the upper layer protocol has to be handled the data. Similarly, next one we have something called as off limit. So we have something called as here off limit. What do you mean by off limit? Off limit with this off limit with certain value will be decremented by one by one by each router. When it passes through when the datagram passes through each router, the value will be decremented by one by one. And when the value becomes 0, the datagram will be dropped. So this will avoid the infinite looping of the datagram in the internet. So with respect to IP version 4, you can see here we have in IP version 4 that is something called as time to leave. The equivalent field in IP version 6 is something called as off limit. When the datagram, here the off limit is filled with a certain value. When the datagram passes, or the packet passes each router, that value will be decremented by 1 each time until it reaches 0. So when it becomes 0, the packet will be dropped from the and the message is sent to the sender by using ICMP protocol. So this helps actually to avoid the infinite looping of the sum of the packet. If the sum packets loops inside infinitely in the internet, then that leads to congestion. So that can be avoided by this one. Next one is source address and destination address. As I told, source address is like 128-bit address and destination address is 128-bit address. So 128 bits address. So 128 bits means let me write here. IP address is 32-bit. 32-bit means 4 bytes. IP address is 4 bytes. So here it is like 128 by 8. This is around 16 bytes address. So IP version 6 is 16 bytes address. Other than that, we have here, 1 minute, data followed by data. So now what is the speciality of this one from IP version 4? In IP version 4, there is something called as in IP version 4 there is something called as fragmentation, but in IP version 6 there is no fragmentation. In IP version 6 there is no fragmentation is allowed. Then how it will work? There is no fragmentation is allowed. That means IP version 6 does not allow for fragmentation or reassembling by reassembling at the intermediate router. These operations are performed at the source router and destination router. Suppose if the intermediate router receives the fragment which cannot be forwarded further, that means the link the particular data link of the router cannot handle that fragment with the particular size, then the fragment will be dropped and the message is sent to the sender by using ICMP protocol. So here one thing you have to remember, there is no fragmentation in IP version 6. Second one is I will take you to this here IP version 4. Here you see adder checksum. This adder checksum is used to provide the integrity of the data. It will do the checksumming of the data, whether the sender data is received properly or not. So same option is here in IP version 6. The same option is avoided. IP version 6 doesn't have that option. That means why that option is not there in the IP version 6? You know, above network layer there is a transport layer, and below network layer there is a data link layer. Both will provide the checksumming. Then the designer of IP version 6, they thought, then if they provide once again this checksum option in the design, that becomes redundant function. That's why they have avoided that option. Next one is the options. So if you go to IP version 4, there is an option is there. So if options are there, that will increase the adder size. So without option, adder size is 20 bytes. If the options are there, adder size will increase. Option something like timestamp or other things and all. So this one is also been avoided in the IP version 6. Instead of option, next adder is used. So next adder will give the clear indication which adder has which gives the clear indication which is the next adder has to be processed instead of options. So instead of options. So this is the IP version 6 datagram format. Now we will see the next topic. The next topic is transition from IP version 6 to IP version 4 to IP version 6. So we know all the routers cannot be upgraded simultaneously from IP version 4 to IP version 6 in the world. In between, some of the routers are operating with IP version 4 and some of the routers are operating with IP version 6. So if the IP version 6 packet will be sent through IP version 4 router in between, then how the IP version 4 router will treat the packet. That is the main thing, and that concept is called as a transition from IP version 4 to IP version 6, and the concept is called as a tunneling. You will see that one now. So exactly how the transition from IP version 4 to IP version 6 happens. What are the approaches are used here? Here two approaches are used. One is called a dual stack approach. Second one is called a tunneling. So what is the difference between dual track approach or tunneling approach? What is the advantage and disadvantage of this approach? All these things we will see in the next session. Thank you.